Welcome to Automated Visual Software Analytics. In this first part, I would like to give a course overview. In particular, I would like to present the course contents, the learning objectives. We will introduce the CLIP structure used in this course, and I will give you details about the course organization. I'm Jürgen Dollner. I'm with the Hasso-Plattner Institute for IT Systems Engineering, and the course topic, Automated Visual Software Analytics, is among my personal research fields related to information visualization, software analytics, and software engineering in general. Now let's start with the course contents. The purpose of this course is to outline and to motivate a topic that could be called Automated Visual Software Analytics. So it's analytics, it's specific to software, therefore software analytics. It uses information visualization technology. For that reason, it's called Visual Software Analytics. And finally, most of the processes behind work in an automated way. For that reason, it's called Automated Visual Software Analytics. From my perspective, this is a key methodology and technology that aims at improving effectiveness of software development and software engineering in general. So it's applicable to all branches, to all domains, to all types of software projects. Of course, its main intent, its main purpose is for large, complex, long-term software projects, for example, in the case of legacy system or big enterprise application. But it's not limited to these large projects. It's also applicable to smaller projects, for example, in initial settings where a new software system, a complex software system is being built. So the scope is very generic, very broad, and the key topic is Automated Visual Software Analytics, methodology and technology. This course outlines the topic and includes related fields in different disciplines. These different disciplines include software engineering on the one hand, and on the other hand, information visualization. It also includes parts of analytics, especially big data analytics, visual analytics, and aspects of predictive analytics. And finally, it covers core topics in software analytics, in specialized methods and techniques for software engineering data. So these are the four key and principal fields this course will cover. Now let's have a look at the prerequisites. What do we expect and what should you know before you start this course? What is beneficial and what do we assume that participants should have or should be interested in? We assume that you have, let's say, a basic experience in software engineering and software development projects. Maybe you are even an experienced software engineer or software developer or team leader or manager. What we also assume is you have participated in software development projects in one or more roles, for example, as a team leader, as a software architect, a software designer, software developer, or tester. So there are many rules around software engineering. So it is helpful if you got experience in one of these rules. What do we also assume? You have been exposed to aspects of long-term handling of software-based projects. Long-term means, for example, software maintenance. This is a typical field of application for software analytics, and it's part of the reality of software engineering because once a system is built, it has to be extended and managed over typically a long period of time. So we expect that you have some experience in that field with long-term handling of software projects. What we also assume is that you want to know more about methodology of IT development. Methodology means frameworks, concepts, methods that help to organize, to optimize the handling of software development projects. So this is what we expect. We also want to make clear what we do not deliver. What this course does not deliver, for example, it does not give a first or general introduction to software development or software engineering. Of course, it covers several aspects of software engineering, and maybe you are not familiar with these aspects, so it's a chance to refresh or even to get in touch with these issues, but in general, we do not introduce software engineering. We expect that you have some previous knowledge there. Yeah, this course does not introduce any new modeling approaches or new programming languages or new programming paradigms or new programming or development frameworks. We assume that you have your framework, your programming paradigms, your programming language you are familiar with, or which is set and defined by the context in which you are working. But this course does not deliver any new modeling technique or programming language. It does not deliver those technical, innovative aspects. It delivers innovative aspects regarding the methodology and the handling of long-term complex software projects. This course does also not deliver or provide any tricks or best practices for programming, for software design, for software architecture. Of course, this course does talk a lot about how those best practices can be seen through the perspective of software analytics and how software analytics can help to detect and to put into practice best practices. So we will also a little bit cover these aspects, but it's not the core contribution. Also, this course does not give instructions or solutions for solving any specific, domain-specific software development issues. So we assume that you are familiar with or that you are challenged by your own software projects, and what we can do is we can tell you how software analytics possibly can help you to get a better understanding, better insights, even actionable insights into large, long-term software projects. So now let's see what are the contents. The contents are distributed into 4 principal areas. One principal area is software engineering. So we will investigate a few aspects of software engineering, especially software complexity, software quality, software metrics. We will also have a look in the context where software analytics takes place and where software analytics is important, such as in software maintenance, dealing with software repositories, doing software developments and version control systems. The next principal area is analytics. Analytics is used already in a number of disciplines, in a number of economy branches. Analytics can be differentiated further by visual analytics, analytics that uses visual technology, predictive analytics, and big data analytics. So we will also have a deep look at these 3 principal forms of analytics that are relevant for software analytics. We also will have a look at the visualization technology used typically by software analytics, including the general visualization pipeline model and a few concrete visualization techniques such as tree maps, 2.5-dimensional tree maps, and bundle views. So these 3 areas contribute and are being used by software analytics. In software analytics, we will get a detailed view on software maps, a key and principal tool that is used by software analytics. And we will investigate different forms of analysis, system analysis, dynamics analysis, process analysis, and related technology. We will also have a deeper look on mining repositories, decision support, software DNA, and prescriptive analytics as some topics that also give a further outlook on the field. So these are the principal components of this course you can expect. It's distributed, the contents is distributed among several weeks. So in the first week we have the introduction to software engineering, whereas in the second week we will talk about software metrics and their application to software analytics. In the third week we talk about analytics and how this technology is used for software analytics. In the next week we will go into automated data mining, especially version control system mining, software repositories. We will also go into detail about visualization techniques, such as the tree maps and the bundle views. And in the next week, we apply, or we have a look at applications of visual software analytics, especially software maps and different software map themes, such as for exploring system implementations, discovering error-prone code, monitoring technical depth, involvement in knowledge distribution, refactory planning, monitoring redesign processes. Maybe this list is quite important if you ask, oh, what can I do with automated visual software analytics? Where does it help? What can I expect from software analytics? So these parts are the practical parts where we get in touch with a software analytics tool as well. And also this somehow clarifies the ultimate purpose, the ultimate goal of software analytics, namely to answer those questions and to offer tools for these challenges described here. In the final week, we work on related techniques and take an outlook. For example, we look at tracing technology for recording runtime behavior and related visualization techniques for analytics purposes, such as trace views. We also look at code usage and test coverage and how it can be used for software analytics. We will finally talk about software effectiveness and prescriptive software analytics. So that's the content and its alignment to the weeks of this course. What are the learning objectives? I tried to summarize the learning objectives in these bullet points. One is to outline concepts and methods from scientific fields that contribute to software analytics. Also to describe objectives underlying the data-driven software engineering approaches that are inherent to software analytics, moving software engineering from an empirical science to a data-driven science and even data-driven practice. Yeah, we also want to discuss, or the participants are able to discuss challenges for software maintenance due to software complexity and software dependency. Participants also should be able to list, describe, and compare software metrics as important quality measures used in software analytics. Participants also should be able to outline and contrast different visualization techniques used by software analytics. Yeah, and to obtain first experience in using automated visual software analytics tools. This is actually an important part of this course, that we get some practical experience in using software analytic tools. And finally, at the end of this course, you should be enabled to reflect on using elements of automated visual software analytics in your own projects as a means to improve effectiveness of software development processes, to improve effectiveness of what you are doing and what your team is doing. So let's talk about the clip structure. Every part, every clip for these parts has a structure that is outlined here. It starts with a course title, the course topic. The topic also includes the contents of the individual clip. Then we have several slides for the contents of a given clip. It's always finalized by a summary that summarizes the contents of the clip. Then this is the clip topic end slide, and beyond this slide, after this slide, we have typically 1 or 2 slides with terminology introduced, that is definitions of certain terms. We provide further reading hints, and at the end I will give my personal remarks for each of the topics of each clip. So this is a general clip structure. I hope that you will find this very convenient, especially the summary and terminology slides may help you to organize all these terms we will get in touch with. Yeah, that's the clip structure. Let's go to the course organization. We have 6 lecture weeks. The final exam is in week 7. We have several lecture units per week, and per unit there are these slides, a video, non-graded self-tests, and we provide you readings, mandatory or optional. We will always clarify this, and sometimes optional analytics tasks with respect to use cases we will provide you. And the week is finished with a graded assignment, and there are 6 graded assignments that sum up to 90 points. The graded final exam has also 90 points and together 180, and the Open HPI certificate is awarded if you get more than 90 points in total. So this is a general setting in these online courses at HPI. We also maintain and added a forum that can be used to discuss with other participants and the teaching team members. The frequently asked question site is also constantly updated. So that's about some details about the organization. I also have to inform you about some formal and legal aspects. They are summarized here. Basic message is that we do not provide any warranty or conditions of any kind, but you most likely are familiar with this type of formal and legal notices. Please read it carefully, that you understand what are the limitations of this course with respect to the legal aspects. So, I hope this helped you to understand and to see what this course will deliver. I will end with some personal remarks. We explicitly invite participants that are involved in software development project, including those members at a, let's say, high level of abstraction, such as the C-level, CTO, CEO, CIOs. It might be also useful for these persons, because software analytics, it's a broad instrument for different stakeholders of the software engineering process. Of course, we explicitly invite participants that are confronted by seeking future-proof methods to handle large, distributed, complex, or even sometimes wired software projects. Software analytics provides some means to handle even those sometimes difficult challenges. We explicitly invite participants that work as consultants in the field of IT, because software analytics, it's a wonderful, perfect instrument for doing better consultancy, to get faster insights that are needed. Last but not least, of course, initially this topic is directed towards all professionals in software engineering, IT development, and of course, big data analytics. So, yeah, in summary, software analytics is useful for a broad audience, and see for yourself whether it's interesting regarding your personal, your professional work. And software analytics in general involves so many stakeholders. It's not a non-complete list here, so you can expect several aspects that are relevant for most teams that are working on complex systems. Typically, these systems are software-based, so software analytics also has much to tell about the development of complex systems as well. Yeah, I also should mention that we will get access to a software analytics system from the HPI's research partner, Software Diagnostics, and this tool will be used to get practically experience with software analytics. This will be subject to the use case part related to software maps. So that's all for the introduction, for the course overview. I hope to see you during this course, and I hope you will enjoy this course and its topic, Automated Visual Software Analytics.